So hello नमस्कार to the all chemistry lovers and doctors and engineers of the near future. मैं विजय कुमार सोनी आपका हार्दिक अभिनंदन करता हूं रिगार्डिंग टू जस्ट केमिस्ट्री इन केमिस्ट्री वाला चैनल। प्रीवियस वीडियो तक हमने बहुत सारी इंपॉर्टेंट बातें जान ली हैं रिगार्डिंग टू जस्ट स्टीरियोकेमिकल एस्पेक्ट्स ऑफ एसिड रिएक्शन। फर्स्ट बात की हमने सिंपल लाइट की, फिर बात की हमने पर्टिकुलर निकोल प्रिज्म की, थर्ड बात की हमने बहुत इंपॉर्टेंट प्लेन पोलराइज्ड लाइट। आज इसी सीक्वेंस में आगे कंटिन्यू रहता हूं। दैट इज द फोर्थ टॉपिक इज नॉन एज ऑप्टिकल एक्टिविटी। दिस इज द ऑप्टिकल एक्टिविटी। दिस इज वेरी इंपॉर्टेंट टॉपिक। दिस इज वेरी इंपॉर्टेंट टॉपिक। आपको अच्छे से सुनना है, अच्छे से समझना है। विदाउट डूइंग दिस टॉपिक यू कांट डू anything in optical isomerism or just stereochemical aspects of acid reaction. बात करूं तो डिस्कवरी की, फर्स्ट ऑफ ऑल इट वाज डिस्कवर्ड बाय अरेगो। डिस्कवरी बाय अरेगो। अरेगो ने पर्टिकुलर इसको डिस्कवर किया इन ऑर्गेनिक कंपाउंड, इनऑर्गेनिक कंपाउंड पर्टिकुलर सोडियम क्लोरेट NaClO3 में इसको डिस्कवर किया। बट वी आर टेकिंग दिस ऑर्गेनिक केमिस्ट्री सो इट वाज नॉट यूजफुल फॉर अस। इन्हीं के स्टूडेंट लाइक यू मीन्स यू आर द स्टूडेंट ऑफ मी, देन नो डाउट इन्हीं का एक स्टूडेंट था बायोट। आपने डिस्कवर किया ऑप्टिकल एक्टिविटी को। Explain optical activity in organic compounds such as lactic acid. It is very important. We'll go with the structure also. Lactic acid, glucose, fructose and glyceraldehyde में आपने इसको एक्सप्लेन किया। इट वॉज द जस्ट लिमिटेड कंपाउंड। सो डिटेल्ड स्टडी were proposed by Lewis Pasteur. This is the Lewis Pasteur. If we'll go with the just optical activity according to just your Lewis Pasteur, he told us when we pass just plain polarized light through a compound, through a solution of compound, then there may following two situations मीन्स आपके पास में सिंपल लाइट थी, उसको आपने निकोल प्रिज्म से पास किया। निकोल प्रिज्म से पर्टिकुलर चेंज हुआ सिंपल लाइट इन प्लेन पोलराइज्ड लाइट बाय रिफ्रैक्शन एंड रिफ्लेक्शन। तो उस प्लेन पोलराइज्ड लाइट को जब आप किसी भी कंपाउंड से सॉल्यूशन स्टेट में पास करेंगे तो आपके पास में दो कंडीशंस हो सकती है। फर्स्ट, इफ देयर इज नो चेंज इन PPL मीन्स प्लेन पोलराइज्ड लाइट में कोई चेंज नहीं हुआ, देन that compound will optically ऑप्टिकली इनएक्टिव, यानी कि वो कंपाउंड ऑप्टिकली इनएक्टिव होगा, किसी भी टाइप का ऑप्टिकल आइसोमेरिज्म शो नहीं करेगा। मींस does not undergo just your optical isomerism. Optical isomerism. This was the first condition. Second condition, if there is rotation of plane polarized light, plane polarized light by that compound, then such phenomenon means rotation of plane polarized light. Such phenomenon called as optical activity. Optical activity means that compound will optical active. Optical active means it exists optical isomerism. What way? Along with the rotation. If the compound rotates to the plane polarized light in clockwise direction, this is the clockwise direction, then that rotation is called as dextro rotation, and that form called as dextro rotatory form. That form is called as dextro rotatory form, and dextro rotation is called as just clockwise rotation, or you can call it D form, or you can call it plus form also. This was the regarding to just rotation of PPL in clockwise direction. While if just the compound rotates to the plane polarized light PPL, plane polarized light, in anti-clockwise direction, then it is known as just levo rotatory, because of levo rotation is called as anti-clockwise. It's a Latin word. Levo rotatory form or and form, or you can say minus form also. So what we can say that there are two optical isomers regarding to just optical isomerism. One of the D form, this is the D form, and or dextrorotatory form, and another is your important, that is the levorotatory form, or you can say L form or minus form. This was regarding to the optical activity, means rotation of plane polarized light is called as just optical activity, and that compound will be optically active. We'll discuss in detail how it may be. See the matter. If we want to go with the further, then diagrammatically it can be explained as follows. As I told you, optical activity is too important. So listen me carefully, because of the all stereochemical aspects are very important. So let's see. This is the simple light. This is the simple light. When we will pass this light, simple light, when we will pass this light through the nickel prism like this is your nickel prism, which acts as a polarizer, and this is the change of simple light in PPL, plane polarized light. If we'll pass the compound, if we'll pass the just simple light, plane polarized light through the compound, this is the sample tube जहां आपको उस कंपाउंड को सॉल्यूशन स्टेट में लेना है, then it will be two conditions like this. If there is no change in PPL, you can say जैसा था वैसा का वैसा मिल जाए, no change in PPL, plane polarized light, then compound will optically inactive होगा compound, no optical isomerism, while there may two conditions. If there is rotation of PPL, one of the as follows. This is the suppose PPL 1. We can take these as follows. Another we can take as follows. Another condition. The rotation may be as follows. Like this, you can say this is the rotation, this is the rotation, like this, one of the as follows, means you can say, I will explain, another may as follows, with the angle of, here will be the angle as a just positive, rotation angle will be taken as a positive because it's a clockwise rotation. This is the clockwise rotation, and this is the angle of rotation again alpha. This will be taken as a negative, and this is called as anti-clockwise rotation. That's why it is also called as deform. This is for the deform, and this is called as L form, means levorotatory form, and this was the rotation, and this property is called as optical activity. Rotation in plane polarized light is called as optical activity. This is the most important thing, and this is the sample tube where we have to take on just the compound. This is the PPL, plane polarized light. Here will be your nickel prism. This was entire part of the just optical activity. One thing is important. If both D and L form as 50% ratio 50%, this is called as equimolar mixture. Then it is called as racemic mixture. This is called as racemic mixture, it will, remember one thing, it's a very important, it will optically inactive, it is denoted by, it is denoted by just either DL, or you can say plus minus mixture also. It will totally optically inactive. This mixture will optically inactive. Why? Because of both are in equal form. So you can say because this is the because both D and L form cancels their rotation. This feature is called as, this is the most important, this feature is called as external compensation. इस फीचर को हम एक्सटर्नल कंपनसेशन कहेंगे. So both D and L form cancel their rotation, and mixture will optically inactive. This was about the racemic mixture, and this was about the optical activity. Now the time to discuss about the fifth important topic, that is too important, that is the polarimeter. If we'll go with the polarimeter, then you can say device through which we can measure optical activity called as just your polarimeter. If we'll go with the polarimeter, then there are four basic parts of the polarimeter. Four parts. Number one is your, you can say, light source. As a light source, we can use the sodium lamp because it gives us monochromatic light with the definite wavelength. Number two is your, just you can say, polarizer. As a polarizer, we will use Nicol prism, which changes to the simple light in plane polarized light. Now the time to discuss about the third part, that is the sample tube, where the solution of the compound has to be taken, and fourth part is your analyzer, through which we can analyze about the rotation, that is the clockwise or anti-clockwise. These are the four important parts of the polarimeter. Now I would like to go with the just ray diagram of the polarimeter. See the matter. If you have any problem, then you can ask me by just comment in the comment box and through the WhatsApp also. So being game, each and everything is important, nothing unimportant. If we go with the fifth part as a polarimeter, then its ray diagram will be as follows. It's too important, as I told you many times, and पर्टिकुलर इससे हम क्या मेजर कर सकते हैं वो भी आपको डीपली अच्छे से जानना है. एंड पर्टिकुलर ये किन किन चीजों पे डिपेंड करता है, पोलरीमीटर के लिए क्या क्या कंसेप्ट इंपॉर्टेंट है उसको आप जानिए. This will be the just your sodium lamp. You can take as follows as a light source. This is the sodium lamp. And this is the sodium lamp. This is the sodium lamp. And 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 this is the sodium lamp it gives us, just you can take as follows as a ray diagram. This is the just ray diagram of polarimeter. So we'll take just here, this is the simple light. This is the simple light, means type of light in which its particle vibrates in all plane with the same velocity. Now here is the polarizer. As a polarizer, we'll use just Nicol prism. Here will formation of PPL. This is the plane polarized light. This is the plane polarized light, like this. Further, it is your sample tube. Its length will be taken in dm, means decimeter. This is the sample tube. Now there may following two conditions, like this. I'll show the conditions as follows, and here will one of the device also, one of the part of polarimeter also, that is as follows. This is the, and this is the eye through which we can see the average change. These are the four parts. As a first part, we can take just a light source. This is the light source, and as a light source, here we'll use sodium lamp. This is the sodium lamp. This is the simple light. Simple light. This is the another second part. This is called as polarizer. As a polarizer, here we'll use of Nicol prism. We have discussed कि particular किससे मिलके बना होता है. This is the plane polarized light, PPL. This is the third part, is your sample tube. Its length will be taken in as a L in dm, decimeter. Here will the change as follows, like this. These are the two conditions. Either it may change as follows, कुछ इस टाइप से, कुछ इस टाइप से, या पर्टिकुलर इसमें कुछ न्यू चेंज आ जाए, like this. You can say anti-clockwise, like this. Here is the rotation angle will be taken in the form of alpha. ये वाला जो एंगल आपको दिख रहा है, इसको अल्फा लेना है. This is the rotation angle as a plus form, क्योंकि clockwise rotation हो रहा है. This is the clockwise rotation. अगर कंपाउंड clockwise rotation करता है, then that is called as D form. We have discussed next rotatory form. Here is the again rotation angle. This is the alpha, but now this will be negative. It is called as anti-clockwise rotation. Anti-clockwise rotation. It is also called as L form. If we go with the fourth important part, then this is the polarizer, just you can say analyzer. And this is the entire part as a ray diagram of polarimeter. This is the entire diagram of ray diagram of polarimeter. So we can show it as follows. Ray diagram of polarimeter. These are the four parts. If we'll go with the further, here will be the measurement of alpha. Here alpha is called as, just here, alpha is called as rotation angle. Rotation angle, as a you can say, just it's a observed rotation angle. ऑब्जर्व, जो कि आपने ऑब्जर्व किया कितना डिग्री है, तो पर्टिकुलर आपने यहां से अल्फा ऑब्जर्व करके और यहां अल्फा ऑब्जर्व करके आपने इसको डिवाइड कर दिया. दिस इज द अल्फा, दिस इज द ऑब्जर्व, डिवाइड किया L इंटू सी से. व्हाट इज द मीनिंग ऑफ L एंड C? आई विल एक्सप्लेन. Then here will be a specific property alpha. This is the T degree Celsius, this is the lambda. Then this is called as specific rotation. Specific rotation, इसको हम कहेंगे specific rotation. Alpha T degree Celsius is equals to just alpha observed upon L into C. This is the important formula to calculate the specific rotation. Where what are these? Just you can say T degree Celsius is your temperature. This is the lambda, wavelength of incident light of here, wavelength of light. If we go with the further, then alpha observed means you can say observed rotation angle. If I'll go with the L, then length of sample tube, it will be taken in decimeter. C is the concentration of solution. You can say it will be taken in mole per liter. This was about the just specific rotation. If anybody asks you particular किन factors पे specific rotation depend करता है, then we can say these also called as just factor affecting just specific rotation को इफेक्ट करने वाले फैक्टर्स हैं. ये था आपके पास में पोलरीमीटर, जो कि यहां से मेजर कर लेंगे हम अल्फा को. अल्फा ऑब्जर्व आ जाएगा. एल लेंथ आपके पास में सैंपल ट्यूब की होगी. सी कंसंट्रेशन गिवन होगा. टेम्परेचर और जस्ट आपके पास में वेवलेंथ नोन होगा. इफ वी विल मल्टीप्लाई to the just specific rotation as a T degree Celsius, this is the lambda, with the M of the compound, this is M, then it will be molar specific rotation of the compound. And specific rotation and molar specific rotation for the particular compound will be specific, its value will be definite. So this is the molar specific rotation, and M is the molar mass of the substance or compound which we are going to take here. This was about the just optical activity and polarimeter. See the matter properly. So इसी सीक्वेंस में आपसे फिर मुलाकात होगी with the new topic. We have discussed just about the just 5 to 6 topics. Either you can say simple light, Nicol prism, plane polarized light. Fourth part we have discussed optical activity, and fifth part as a polarimeter. We'll meet with the next new topic in next video. तब तक के लिए शुक्रिया, धन्यवाद. बट इस चैनल को मैक्सिमम से मैक्सिमम सब्सक्राइब कीजिए, शेयर कीजिए. मेरी आप लोगों से यही रिक्वेस्ट है, क्योंकि ये कारवां अब स्टार्ट हो चुका है. अब तब तक नहीं रुकेगा जब तक कि मंजिल नहीं मिल जाती. विजय सोनी आपके साथ हमेशा है और हमेशा रहेगा. केमिस्ट्री को मैक्सिमम से मैक्सिमम आपके सामने रिप्रेजेंट करेगा. तब तक के लिए शुक्रिया, धन्यवाद.